Hi everybody, welcome to SMR Telugu Education. Next topic is how to create linked list. So linked list is very important concept. In this video we will discuss how to create a linked list and how to display the data and then calculate the number of nodes of a given linked list. So in linked list it can contain data part, next one is next node address. So total thing, this one is called node. So this one is called node. In node it can contain data and next node address. So how to create a linked list and how to display the data and how to calculate the number of nodes of a given linked list. So first of all we are creating the employee data. Here the data may be an integer or employee. In this example I will take data as an employee ID, employee name and then employee salary. This is a called one structure variable. Okay, how to create a structure? Save to save this file, linked list .c. So struct emp. In this structure I am defining int id char name of 36 and then int salary. Here struct emp total size is 40 bytes. Here the integer size is 2 bytes, character size is 1 byte, 36 characters, 36 plus 2 38. Here the integer size is 2 bytes, total 40 bytes of memory is allocated. Here struct emp shortcut name, here I am taking typedef by using typedef struct emp capital EMP. This is a alias name. So in our C program, instead of writing struct emp, directly have to write emp. Here I want to enter this data id, name, salary. By using function I am writing how to scan id, how to scan name and how to scan the salary. Here function name is get data, so no parameters. Here the return type is an employee, capital EMP. So ask the user printf /n enter id. Here I am defining one capital EMP variable, struct EMP variable e. So scan that values, scanf %d comma address of e.id. So printf /n enter name. So name is a character. So after entering the id we are pressing enter. Enter is also character. To clear the buffer, flush all function, flush all and then gets of name e.name. Then enter printf /n enter salary. So scan that one, scanf ampersand e.salary. We are scan the salary name id. This one should be present in this variable. Return that one. So return e. This is for scanning the data. Here I am entering ID, name, salary by using this function, get data function. We have to scan that values and then write the print that data. So no return type, function name is print data. I want to print the employee ID, employee name and employee salary. That's why here I am passing struct emp, capital emp variable as a parameter, printf slash n id is equal to percentage d, name is equal to percentage s, salary is equal to percentage d, comma first one e dot id, e dot name, e dot salary. Here the return type is white. This is for this function for printing the scan the data. This function is for printing the employee details, employee name, employee ID, name, salary. This is for printing purpose. So how to create a linked list? So linked list is a data part and then self-referential structure, next node address. So how to create this structure? So create this structure by using structure name. I want to take link. Here first parameter is data. Data is which type? Capital EMP type data, and then struct link star next. So what is the size of this struct link? The struct link capital EMP, this employee ID, name, salary size is 40 bytes. 40 bytes. This is a structure pointer variable. Pointer variable is 2 bytes. All pointer sizes are equal. Here total 42 bytes of memory is allocated. 42 bytes. Here by using type def we have to create shortcut name for struct link. Type def struct link. I am taking link is a shortcut name for struct link. Here I am writing main function. In this main function I want to write create display and number of nodes. So ask the end user to create, enter 1 for create a links, enter 2 for display links, enter 3 for number of nodes and exit for any number you have to exit that one. Write this menu program by using, so I want to write in infinity loop. How to write infinity loop? There is many ways. Here I am using while of 1 means the condition is always true. So this loop is repeated infinite number of times. In this I am writing printf slash n enter 1 for create links. Copy, control insert, shift insert, paste, shift insert, paste, shift insert. So enter 2 for display links. Display links or display nodes. Our enter 3 for number of nodes. Enter any for exit. Infinity loop. This is the infinite loop. We want to how to exit by using enter any number for exit. Scan that value, scanf %d. I want to enter, take one variable as flag of type integer. Here I am declaring int flag. So end user enter 1 for case 1, 2 for create nodes, enter 1, then you have to write case 1. For display nodes, enter 2, write case 2. For number of nodes, enter 3. For number of case 3, and exit, write default. Here I am writing switch case, I am passing flag. So we are entering 1, the flag value is 1, that means case 1. Then you have to write create. This is a create function, write later, and then break. Then case 2 for display, and then break. So case 3, number of nodes, and then break. For any means default you have to write exit out of the loop by using exit function. So this function is available in process.h header file. So we need to include that header file in hash include process.h header file, F2. Save this one. Okay. Now here we are not writing these functions. For create, comment these lines, display, and number of nodes. First, our execution is always starts from main function. Next, this one is infinity loop. It is display, enter 1 for create nodes, enter 2 for display nodes, enter 3 for number of nodes, enter any for exit, and we are waiting for up to the enter the any value. We are entering 1, then flag value is 1, this value is 1, this one is executed, create, and then break. Break means out of the switch. So out of the switch. Next, once again control goes to, this is infinity loop, this is switch, this one is while. Once again control goes to this one, once again this one is display, enter 1 for create nodes, enter 2 for display nodes. This is infinite number of times. Whenever we are enter 2, flag value is 2, then comes to case 2, this code is executed, and then break out of the switch. Once again this one is display, we are enter 3, flag value is enter 3, flag value is 3, then case 3 is executed, this one is executed, break out of the switch. Next, we are enter any number other than 1, 2, 3, it matches default, then exit. First I want to show you up to this, alt F9, yes, control F9. So enter 1 for create nodes, enter 2 for display nodes, enter 3 for number of nodes, enter any for exit. I want to enter 1, case 1, and then once again while of 1, infinity loop, once again enter 1 for create nodes. I want to enter 2, flag value is 2, case 2 is executed. Once again I want to enter 3, flag value is 3, case 3 is executed, then once again infinity loop. I want to enter any number other than 1, 2, 3, it matches case default, exit out of the infinity loop. So this is menu program. Okay, first you have to create, how to create nodes. Here I am uncomment this code. Whenever you have to enter case 1, where enter flag value is 1, it matches case 1, and then execute create function. This is called function calling. Now we have to write the create function. So no return type, void create, no parameters, and then this is called function definition. So this one is very important. First you have to understand how to create a linked list, and remaining concepts is very easy. Stack and queue all are depends on single linked list. How to create, how to display, and how to calculate the number of links. Okay, first so here there is a three functions. First one is called create function, create, display, and number of nodes. This is one function, this is one function, this is another function. Here I am taking one variable called, one pointer variable called head. So variable name is head. So every variable has some address. Here I am taking some 400. So initial value is some garbage value. So I want to use this head variable in display, create, display, and number of nodes each function. Now we are defining this head as a global variable. The global variable default value is 0. So now we are declaring head variable as a global variable. So we have to, global variables are defined before main method. So before main function, I want to define head variable of which type? So link asterisk. Here the node is, our node is this one, struct link emp data struct link next. This is the node. This address is stored in head. So this is a global variable. The global variable default value is 0. So null ASCII value is 0. So null is present in which header file? Hash in alloc.h header file. I want to run this code, we will get an error. So head is present in, here no need to write null. By default this is a null value. Alt F9, so we will get undefined symbol null. So null is present in which header file? So hash include alloc.h header file. Okay, right. So no need to write null. By default this is a null value. So this is a global variable. Now if head is a global variable, its a default value is null. Now here create, we are enter case 1, it comes here create. Okay. So now starting, if head value is equal to null, so head value is equal to null, then here you have to write one statement. Here create memory for this one is data, so this one is next. This one is data. This one is next. So every data has ID, name, salary. This one is ID, name, salary. So we have to create this node and assign this node address. Some 500 is assigned to head. That means this 500 is assigned to head. So this value is 500. Now this one is pointing to head, is pointing to this node. So how to write this equivalent statement? How to create this function? By using malloc malloc size of link. So 42 bytes of memory is allocated. This one is return type is white pointer. We need to assign to head. Head is which type? We need to typecast that one to link asterisk type. So head is equal to so this statement allocates the 42 bytes of memory, and we need to typecast this one to link asterisk and assign this one to head. This equivalent statement is equal to allocate memory and assign this 500 to head. Now head is pointing to this one. Next, how to fill this data? This one is pointer to, this is a structure struct to dot and arrow. Here we have two operators. Dot is struct to member, arrow is pointer to member. This is a pointer to member. How to access? Head arrow data. We need to enter scan ID, name, salary. Starting we have to write one function called get data. This function, so execute this function, enter ID, name, salary. This is returned to this one. Here ID, name, salary. Next one is we have to fill this one, head arrow next is equal to null. So next node is not available, then this one is null. Here I am entering the ID is 1, name is SMR, and then salary is 16,000. So I want to write this code. So head is equal to link star malloc size of link. Next head arrow data is equal to get data. I am calling this function. Next head arrow next is equal to null, and then return. Now so this code is executed, get data, then this control goes to this function, get data function is executed, then control goes to get data function, this function, enter ID, so enter name and then enter salary and return that one. The return value is replaced in head arrow data, then null value. Here I am asking enter one more node. Ask the end user printf /n, do you want one more? So you want to scan this one. So by using getChar function, so before get char, I want to flush all function to clear the buffer. So ch is equal to get char. Here I am scanning one character, so we need to declare that one char ch. For suppose if end user is enter, if ch value is not equal to small y, then return. So for suppose end user enter, yes, this condition is false, then control comes to this statement. Control comes to this statement. So if when head is not null, then control comes to directly this statement. Okay. So first you have to check up to this. You have to run this code, will get an error. Here we are writing function definition after main method. After main function, we need to declare that one. Here you have to declare that function, otherwise we will get an error. Run this code, we will get an error. Alt F9, one error, type mismatch. So type mismatch in declaration of create. Here you have to write the return type is void, function name is create, and then no parameter. This is called function declaration. Now okay, so Alt F9, yes. First, so I want to show you how to. Our execution is always starts from main function, and then this is the infinity loop, and then enter the flag value. I want to enter 1, case 1. Then function is calling from, control comes to this statement. Starting head value is null, yes, condition true. This memory is allocated. Next, this function control goes to this function, get data function. So ask the end user, enter ID, name, salary. Our enter value is return value is replaced here. Next value is null. Next, do you want one more record? So you want to enter, yes, then control comes here. You are enter no, then return. Okay, so first you have to check up to this one. Alt F9, F7, Windows, watch. Here I am taking the head value. I want to watch this. I want just to show you head value. So Windows, watch. So head starting value is null. This is a global variable. Global variable default value is null. So Alt F5. So F7. So enter 1 for create nodes. Enter. I want to enter 1. The flag value is 1. Then it comes to case 1 create. Then control comes to case 1. This function is calling. Then control comes to F7. This statement. Next control comes to this statement. So F7. So head value is null. So F7. This one is condition true. Memory is allocated. That memory, this allocated memory returns a address. This address is assigned in head. Now head value is 07C2. Now head arrow data. Here we are calling get data function. Then control comes to this function. So F7. So ID, enter ID. I want to enter 1. So F7, enter name, SMR, F7, enter salary. Salary is 16,000. After completion of this execution, once again control the return value is replaced in head arrow data. Now this value is id, name, and then salary. Next this statement is executed. Head arrow next value is null. So F7 null. Do you want one more? So first and ask the do you want one more record? Entering no. Then ch value is no, not equal to yes. Yes condition to return. Return means this out of the function. This is, then control comes to this statement. Once again after completion of the create statement, once again control comes to this line and then break. Then out of the switch, once again these options. So F7 break. So enter 1 for create nodes, enter 2 for display nodes, enter 3 for number of nodes, enter any for exit, and then once again ask the flag value. So I want to enter 4, then exit. Flag value is 4, case 4 not match, then this one is executed. F7 exit, F7 out of the main function. So this is for create nodes if head is equal to null. Now alt F9, yes, control F9. So I want entering 1 for head is equal to null, yes, condition true. Then this statement is executed. Employee ID is 1, employee name is SMR, employee salary is 16,000. Do you want one more record? No, and then exit. Okay. Now, so do you want one more record? Yes. Yes. Here I am entering yes. Then this condition is false. Then control comes to this statement if head is not null. Now yes, this condition is true. Head is not null. So this one is very important. So now I want to remove this code. Next I want to, if head is null or not null. Yes, head is not null. Head value is 500, not null. Yes, condition true. Then I want to create one more node. This one is data. This one is next. This one is ID, name, salary. ID, name, and then salary. Here I am taking one temporary head. I am taking one temporary head th. So I assign this head value to temporary head. Now our requirement is to move this temporary head up to this node, last but one node. This one is last node. We are entering. This one is last node. We need to create this one. We need to create this node. Our aim is to move the th value up to the th value is 500. Now we have to move the th value to the up to the last but one node. This is the last node. This is the last node. this is the last node. We need to move this th to th to the last but one node. So how to write this one? So here take temporary head. Head is which type of variable? Link asterisk th, and move this right to a loop th arrow next not is equal to null, then move th is equal to th arrow next. So this code is for move the th temporary head to last but one node. Last but one node means here we are entering second node. This is the last node. We have to move this th1 to the last but one node. Now the th, now we are create this node. How to create this node? By using malloc function, malloc size of link. So this statement allocate the memory. It gives the base address, some base address. We need to typecast this one to link star or link asterisk. So we need to assign next. So up to this memory is allocated 600. Now this 600 is present in which position? This position. What is this one? How to access this one? th arrow next. So we want allocate this memory and typecast this one to link asterisk and assign this value to th arrow next. th arrow next is equal to th arrow next is equal to link star malloc size of link. So this is statement. This one is allocate the memory. So allocate this one, and this 600 is stored in th arrow next. Our th is pointing to last but one node. This is the last node, last but one node. Now th arrow next, that means this 600 is stored in this location. Next, after writing this code, our th is pointing to which node? Last but one node. We need to move this th to last node. That means th value is 500. th is equal to th arrow next. Now th arrow next is 600. This 600 is assigned to th. Now our th value is temporary head value is 600. Now this 600 is pointing to this node. Now how to access this pointer to member? struct to dot is struct to member, arrow is pointer to member. How to access this data? th arrow data. Now we have to call th arrow data is equal to get data function. Next th arrow next is equal to null. So here id, name, salary. Once again get data function is executed. Here I am enter id to name, so Manvita, salary is 15,000. Next is null. So I have to write this code. Now we have to move the th1 to last but one node and then allocate the memory malloc size of link. We allocate 42 bytes of memory. We need to typecast this one to link asterisk. This address is stored in which location? th arrow next. Now the th is pointing to up to this statement. Th is pointing to last but one node. Now we have to move th to last node. So th is equal to th arrow next. Now we have to point to member. So th arrow data is equal to get data, th arrow next is equal to null. So first we have to check up to this condition. Okay, so once again I am alt F9, yes, control F9, so F7. I want to show you the flow control. So main method, one for create nodes. I am entering 1. So first I have to Windows watch. So starting head value is null. So F7 create nodes. So head is equal to null. Then this code is executed. So enter data. I want to enter 1. So F7 enter name SMR. F7 enter salary is 16,000. Return. So head is null. Do you want one more? Yes. Now I am entering. Do you want one more? Yes. Then this condition is false. Then control. If head is not there, then control comes here. Here I want to debug. So I want to show you th arrow next. So I want to show you th value also. So t head is this value, th arrow next is null. Now temporary value is head F7, th value is this one, th arrow next is null. This value is null. Null not equal to null, condition false, then out of the loop. Out of the loop, whenever this control comes out of the loop, we have only one node. We have only one node, this one. Now we have to allocate the memory, and this allocated memory is stored in th arrow next, and then move this th1 to the next node, last node. So F7 condition false. So memory is allocated. That allocated memory is stored in th arrow next. Now th is pointing to the next node. Now calling this enter id is 2, F7, employee name Manvita, F7, employee salary is 15,000, F7, null. So after completion of out of the create function, then control goes to the break, then break means out of the switch once again. So do you want, so I want to enter 6 exit. Now here I am asking the end user, do you want one more record? Printf /n, do you want one more? Right, flush all ch is equal to get char. So please remember, if I am entering yes or no, I am entering yes, then once again. So please remember, first you have to add is equal to null, then we are enter this node, then I want to enter no. So if add is equal to null, so this code is executed. So do you want one more? Yes. Then control comes here. After execution of this code, th is pointing to last but one node. Here we are allocate this memory and assign that one to temporary head arrow next, and then moves to the last node, and then enter data and null. Do you want one more? Yes. Then next value is, so I want to store, allocate the memory here. So I want to remove this code. Now I am so create a node. So this one is data, this one is next. So here the address is 700. This 700 is stored in this value. That means th arrow next, create the memory and create the memory. This 700 is stored in this location, and then th is moved to the this last node, and then fill this data and fill this data. So no need to write the code. So this one is repeated. So do this one. So do you want one more record? Yes. While th is equal to small y or ch is equal to capital Y. We are entering small y or capital Y. Now, so I am entering, do you want one more record? Yes. Then control goes to this statement. Here create the memory, and this 700 is stored in this location, this null value is replaced with 700. So this one is id name salary, id name salary. Now th1 is pointing to last but one node. You have to move this th is equal to th arrow next, then th arrow data is equal to, you have to call get data function. Next th arrow next is equal to null. So do you want one more? Yes. Then once again create the node. This address is stored this location. So this one is null. So this one is repeated. Okay, so now first you have to check. Once again I will show you the execution. So execution is always starts from main function. So F7 and 1. So now head is equal to null. So here I will show you. Watch. So F7 head value is null. Create nodes. Then control comes to this function. So head is equal to null. Yes, this code is executed. 1 employee name SMR, employee salary is 16,000. Next, do you want one more record? Yes, I want yes. Enter yes. Then this condition is, so first I want to, this condition is false, then control comes to this statement. So F7 next th arrow next value is null, this value is null, null not equal to null, condition false, out of the loop. Now th is pointing to, th and head both are pointing to the same node. So F7 point same node. Next create the memory and allocate the address to temporary arrow next. Next th is address is changed, th value is, this value is changed to this one. Now this function is executed, then control comes to get data function, employee id to employee name. So Manvita, employee salary is 15,000. So return value. So do you want one more? Yes, I want enter yes. Then this can do while loop, then this once again we have to create the memory, and this address is stored in th last but one node, and then move to th to the last node and then fill the data. So do you want one more? F7 yes. 3 employee name Vishal Kumar, employee salary is 17,000. So F7. So do you want one more? Yes. Once again yes. Then once again control goes to this, th is pointing to last but one node. Now we have to create the memory. This is the last node, and assign that address to last but one node, and then move to th to the last node, then get data. F7 yes. Employee id is 4, employee name is Shanmukh Verma. F7 employee salary is 18,000. So F7. So do you want one more? No. Then out of the create, so out of this switch, next once again Now I am entering 1. Do you want create 1? Now F7, control goes to here. I will show you F7. Watch. Now our head value is available. Head is not null. Here I will show you so F7 create links. So in this example, so total we have 4 records: ID, name, salary, ID, name, salary, and then null. Here I am entering 3. Name is Kushal Kumar. Salary is some 18 or 17,000. This 700 is stored. This is 800. So this one is stored here. So this should be replaced with 800. Now this one is ID, name, salary. ID is 4. Shanmukh Verma. Salary is 18,000. And then null value. So total 4 records. Now if head is not null, then control comes to this statement. If head is F7, head is not null, then control comes to this statement. So control comes to this statement. Now we have total 4 records. Now the TH is pointing to, after this loop is repeated up to TH is pointing to the last 4th node. So in this example, 4th node is this node, 800 node, and then we have to add the one more record, add record, and this address is stored to this location is this code. So F7, so TH arrow next, first 1, 2, 3, TH arrow next. Now TH is pointing to last node. Allocate the memory, last but one node, allocate the memory and assign that address to TH. Now TH is moved to the next location. Once again data, get data 5, ID is 5, F7, name Durga Ganesh, so F7, salary is 19,000. So F7. So do you want one more? No. So F7, break. Once again. So once again one more. No, total we have 5 records. So F7, create nodes. Control comes to this one. So head is equal to null, condition false. Then control comes to this statement F7. Now this one is, after execution of this code, TH is pointing to 5th node. 1, 2, 3, 4. Next TH arrow next false, out of the loop. Now next node, 6th node is memory is allocated, that address is stored in 5th node next. Now TH is pointing to next location. This TH value change it to null. Now TH arrow data, enter 6. So F7, name Lakshmi. So F7, salary is 19,000. So F7. So do you want one more? No. So create out of the switch, entering 8 out of the while loop. So this is for create. Next, whenever you are enter the case 2, it is called display. Now you have to write the display function. So write display. Now first you have to check if head is equal to null, then print list is empty /n list is empty, and then return. Here I am taking the head is assigned to temporary head. Temporary head is which type? Link star temporary head. So th is equal to head. Now I have to check the condition. While th not is equal to null, I have to print the data. So print, there is a function called print data function, th arrow data. How to access data? You have to pass employee ID, name, salary. Then you have to execute the print data function. This print data function parameter is capital EMPE, so employee. Next, th is equal to th arrow data. Next, th is equal to th arrow next. So it displays all the nodes data, first node, second node, third node, up to the end of. This is called function definition. So to run this code, we will get an error. We have to declare that one. Alt F9 will get an error. Type mismatch redeclaration of display. Here you have to declare this function. So void display. This is called function declaration. So F7. So case 2, list is empty, head is null, then list is case 2 display. Control comes to this statement, head is equal to null, list is empty, and then return, and then back to break. Out of the switch, once again infinity loop, create one. F7, yes, head is equal to null, true. So memory is allocated, employee ID 1, employee name SMR. So employee salary is 16,000. So F7. So do you want one more? No. So F7, break. Out of the switch, once again while loop 2, display case 2 display. Control comes to this statement, head is equal to null, condition false. Then control comes to this statement, th is equal to head, th not equal to null, true. Then print data, control go to print data function, and this statement is executed. Once again, after completion of this function call, comes back, th value is null. So null not equal to null, condition false, out of the loop. Then break. Out of the switch, Alt F5, one employee. So while loop flag. So I am entering 1, F7, create, head is equal to null, condition false. Then this code is move last but one node, memory is allocated, that node, ID 2, name, Manvita, salary is 16,000. So F7. So do you want one more? No. So F7, out of the, after completion, create break. Out of the switch while 2. So display case 2 display, head equal to null, false. First th value is not equal to null, true. First employee data, next node. Second node not equal to null, true. Second employee data, next th value is null, not equal to null, condition false, out of the loop. Break. Out of the switch, then 3. So F7, break out of the switch by mistake, 1, enter 1. Third employee details 1, head create, false, last but one node 1. Next this is third record 3. So Kushal Kumar, so F7, salary is 16,000. So do you want one more? No. So total records out of the create, out of the switch. Once again 2, number of records is 3. Display, this loop is repeated 3 times, 1, 2, 3. So out of the loop, out of the switch, once again while loop, 1, case 1, create, false. This loop is up to last but one node, allocate memory, and then move to last node, data, enter data 3. Shanmukh Verma, salary is 15,000. So F7, do you want one more? No. Okay, next one is for number of employees. So directly here I am printing printf number of nodes. This function return type is integer, %d comma number of nodes. Now we are entering case 3. Then you have to, this code is executed, you have to write the number of nodes. So return type is int number of nodes, no parameters. Here take, so int number of links, initial value is 0, if head equal to null, then return 0. Return 0, otherwise take temporary head, so th is equal to head, while th not is equal to null. Every time you have to increment the one node, plus number of nodes, th is equal to thr next, then return number of links. So alt F9, yes, control F9. So first one, number of nodes is 0. So 1, employee ID 1, employee name SMR, salary is 16,000. Do you want one more? No. Next display 2, number of employees, number of nodes 1. So 1 for create links 2. So Manvita, salary is 15,000. Do you want one more? No. Display 2 employees, number of links, number of nodes 2. So 1 employee ID 3, employee name Kushal Kumar, employee salary is 16,000. Do you want one more? No. 2, 3 employees, number of nodes 3, number of nodes is 3. For 4, 7, exit anything. So this is create, display and number of nodes. So please remember, this function return type is integer. There is no need to declare that function. Here the declaration is optional. So there is no need to declare that one. So Alt F9, yes, Control F9. So exit 8. So still you have any doubts, please refer once again. Thank you for watching. Hi everybody, welcome to SMR Telugu Education. So next one is in linked list concept, how to insert a link. Insert in linked list. So we already know how to create, how to display and how to calculate the number of links. Now we have to how to insert a linked list. Here the starting maybe head value is null. Some address, so initial head value is null. Head value is null. Then we have to create a link. Allocate memory. So this is data, this is next. And assign the starting address is some 500. So this 500 is stored in this location, this location. Now so here control insert, so enter 4 for insert links or insert nodes. Insert nodes. Here I am writing case 4. Case 4. Here I am writing the function name is insert and then break. So now our execution is always starts from main function. So this is infinity loop. This message is displayed. You have to enter the any number. We are entering 4. Then control comes to this statement case 4. So insert Alt F9. Yes. So control F9 will get an error. So control F9 will get an error. We need to write the insert function. Here I am writing the name of the function is insert, no return type, void. Function name is insert. So no parameters. Here you have to first check the head value. So here, so this is called a function definition. So we need to run this code, we will get error called type mismatch. Get error type mismatch in declaration. You have to declare this one. How to declare? So this is called return type, no return type, insert. This is called function declaration. Now head is a global variable. Starting head value is null. So first here we have to insert the node. So this is the first case. In first case, this is case 1. If head is equal to null, then you have to create this memory and assign this address to head, and head arrow data is equal to get data, Next head arrow next is equal to null. So if head is equal to null, then create malloc size of link. So this size is 42 bytes of memory is allocated. This one is which type? Head is which type? We have to typecast that one to link asterisk and assign to head. Semicolon. Next head arrow data is equal to get data. Next head arrow next is equal to null. Then return. After completion of this one, you have to return this one. So here ID, name, salary. ID, name, salary. So ID is 1. So SMR, salary is 16,000. 160 rupees. Next is null. So Alt F9. Yes, first I will show you the execution. F7. So execution is always starts from main function. So here I am entering 4, then case 4, flag value is 4, then control comes to case 4. Insert function is calling. So this code is executed. If head is equal to null, yes, condition true, memory is allocated, head arrow data, control goes to get data function and ID is 1 and name is SMR, then salary is 16,000. So return value is replace assign and head arrow data, head arrow next is equal to null and then return. So break out of the switch, once again infinity loop. So I will show you display 2. So F7 display printing the data. Alt F7 one data. Now so Alt F7 is Alt F9 is okay. Next one is first you have to calculate the number of links. You have to display into number of links or number of nodes. We already know the function. There is a function called number of nodes. So printf number of nodes is equal to %d comma. Here I am calling. So number of NL is equal to numbers of nodes. So this is the function name, number of nodes. So this function is calling, it returns the number of nodes. This number of nodes is available in NL. So it will printf number of nodes is equal to %d comma NL. Now ask the end user to enter the position to enter the node. So in this case, so number of nodes is 1. So number of nodes is 1. For suppose I entered the position is 10. So it is not valid. So in this case, see position value is in between, the position value is maybe sometimes position value is less than 0 and position value is greater than number of links plus 1, then insertion is not possible. If position value is less than 0 and position value is greater than number of links plus 1, here the position is either 1 or 2. By mistake we are giving position number is 3. It is not possible to insert the node. We have to check that condition. So printf /n enter position to insert. So scanf %d comma address of position. Here you have to declare the position as an integer variable. So int position. So here you are checking if position value is less than 0 or position value is greater than number of links plus 1, then printf invalid position then return out of the function calling. So if control comes to this location means so insertion is possible. So first you have to check if head is not null, then you have to insert the this one. Second condition is if number of links is equal to 1, first we have to check up to this. So alt F9, yes, F7, yes. So I am entering 4. So F7 insert. First I will show you head. So F7 head value is null. First here the number of nodes. So head value is null. Yes, condition true. So return 0. Number of nodes is 0. Alt F5. So number of nodes is 0. Now so head value is null. Yes, condition true. This code is executed. ID is 1. Then name is SMR. Next one is salary is 16,000. So return F7. Next null, then return. So out of the break, out of the switch, once again I am entering 4. So case 4 calling insert function. So control comes to this statement. Now number of nodes is 1. th is equal to 8. 1 increment by 1, false, return 1. Return value is replaced assigned to NL. So F7 number of nodes is 1. Now F7 asks the position. Here we are entering either 1 or 2. Either 1 or 2. So F7 so enter the position. Here I am entering 10th position. So 10 less than 0. Condition true. 10 greater than number of links plus 1. Yes, true. Then invalid position. Alt F5. Invalid position. Return. So once again. So this one is working up to this one. Now, so we are entering. So in this. So number of nodes is 1. This is another case. Number of nodes is 1. Then we are entering, here I am entering the position number is 1. we are entering the position number is 1. That means data is inserted first node. So how to write? Here the data is so this is first node, the memory is allocated. So data, then next, then next. Now here we are entering the position number is equal, this is the next condition, if position number is equal to 1. That means we are enter the node in first position. Here if position number is equal to 1, allocate the memory. So allocate the memory. This one is data, this one is next. In data, this is ID, name, salary. ID, name, salary. So how to allocate this one? So by using malloc function, malloc size of link, we need to, so up to this memory is allocated. Here we have to assign this one to one temporary head. Here I am taking one temporary head th, some address 450. So this value is some 300. This 300 value is assigned to temporary head. So here 300. Now this one is so assigned to this location. So how to fill this data? So we need to typecast this one to, so here I am taking one temporary head th1 is equal to, so here I am taking the temporary head th1 or th, our wish, variable name is our wish, th1 is equal to, here I am taking th1. So you need to typecast to link asterisk malloc size of link. Now this is the th1. Up to this the memory is allocated. First you have to fill this data. So how to fill this data? th1 arrow data is equal to get data next th1 arrow next is equal to, first fill this data. So this is the first node, then first node we have to fill the data. Here I am entering the data is 2, so name is Manvita, salary is some 100 rupees. Next, this is the first node, then this next node is 500. This 500 is present in which location, which variable? Head. That means th1 arrow next is equal to head. So head value is 500. Now this 500 is stored in next. Now this one is pointing to this one is pointing to this node. Now after filling this data, this should be head. First node should be head. That means this head value is 300. So how to write? This head should be replaced with 300. Now this one is pointing to this one. Next, this link is deallocated. So after filling this data, we need to change head is equal to th1. Then this is temporary head. No need assign th1 is equal to null. So no need to write. After completion of the function calling, it is automatically, this is null. This is a local variable. So t1 is equal to null. So next, this value is null. So now what is the value of head? 500. So what is the value of head? 300. This is the first node. Then this is the second node. So now we have to write this code. So if position is equal to 1, then you have to check the condition. If position is equal to 1, then take one temporary head, declare that one. So link star temporary head 1, th1, then th1 is equal to, first you have to allocate the memory, malloc size of link. So convert this one to, we are assigning th1. th1 is which type? Link asterisk is equal to th1. So first you have to fill the data. th1 arrow data is equal to get data. Next, th1 arrow next is equal to, this is the next, is equal to 500. 500 is present in which variable? Head is equal to head. Next one is head is equal to, next head value change it to th1. After completion of this one, th1 is assigned to null. So no need to write. If you write, is not a problem. Then return. This is the position number 1. So we will check this code. Alt F9, yes. So F7, execution is always starts from main function. So Alt F9, yes. Control F9. So 8. So F7, main function. So infinity loop. So I am entering 4. Insert. For starting head value is 0. Then control comes to case 4. Insert. Then we are calling insert function. This code is executed. Yes. Number of link nodes is 0. Alt F5, number of nodes is 0. Starting head value is 0. Then memory is allocated and then enter employee ID 1, employee name, SMR. So employee salary is 16,000. So F7. Next arrow next is equal to null, then return. So F7, and then out of the switch, and then once again while loop. So please remember, single linked list is very important. If you learn single linked list very clearly, remaining concepts on linked list is very easy. circular linked list, double circular, or anything is same procedure. So enter any. Once again I am entering 4. Here now the number of links. F7 case 4 insert. So insert function. So F7 number of nodes is 1. So return, the return value is replaced here. All. Now here I am showing the head value and th1 value. So edit th1, delete this one, th is delete this one. Okay, Windows. If head is equal to null, then condition false. This condition is false, then control comes to this position. So F7, enter the position to insert. Here I am entering the position number is 1. The position number is 1. This condition is false, then control comes to this statement. This statement says position is equal to 1. Yes, condition true. So watch. Now F7, the memory is allocated. That memory, now the th1 value is changed. Now th1 value is 00882. Now th1 error data is equal to get data. So F7, enter ID 2, enter name, Manvita, salary is 15,000. Now F7, now th1, in before the th1 value is, this head value is 0054 is changed. th1 error next is equal to head. Now head is equal to th1. Now this head value is changed to 0882. Now th1 value is null, and then return. Then out of the switch, once again so please remember, whenever the control comes out of the insert function, this memory is deallocated. This scope is only within this function, but head scope is all functions. So F7, now I am entering 2, display nodes. 2, F7, control comes to display. Our first node is 2, Manvita, head is equal to condition false. Our first node is Alt F5, 2, name Manvita, salary is 15,000. So F7, second node 1, SMR 16,000. So F7, out of the loop, out of the switch, once again main function. So this is the case 2. So if position number is 1, then you have to insert the here. Next one is position number is other than 1. Other than 1, anywhere. Okay, either end or middle or anywhere. So how to write this case? So this one is head, this is the second node, this is the third node, this is the third node. This is the next node address, next node address, next node address. Next node. This is the first node, So data next. So this one is data next, data next. So this is the data, then next. Here I am taking the starting address is 500, next address is 600, next address is 700, next address is 800. So here next node is 600, so 600 is stored here. So this one is pointing to this address. Here the next node is 700. Now we have to move this one is pointing to this node. Here the next node is 800. Now this one is pointing to this node. Here ID name salary, ID name salary, ID is 1, name is SMR, salary is some 16,000. Here ID name salary 2, Manvita salary is 15,000. So ID name salary, ID is 3, Kushal Kumar, salary is 14,000. Here ID name salary, ID is 4, Shanmukh Varma, salary is 17,000. So next is not available, then next node is null. Now here the head value is 500. So head is pointing to first node. Now you have to insert any position, either 2, 3 or 4 or 5, any position, or 6, 1, 2, 3, 4, 5 or 5. Here 4 nodes are there, then you have to enter either 1, 2, 3, 4 or 5. Okay. Here I am entering, I want to enter the node at position number 4. Here I want to enter the node at position number 4. Now we are enter the position number is equal to, so position number is equal to 4. Then how to insert that one in 4th position, or not only 4th, or any position other than any position. Here how to do it, how to do this? First you have to take one temporary head. So temporary head th1, so assign this temporary head to temporary head and move this T1 to up to the this location. Now th1 is pointing to, th1 value is 700. Now this one is pointing to so this is the 4th position. We want to insert this. So take the temporary head th1 is equal to, we are moved this th1 to the th1 to the 700 before this node, and allocate the memory for th2. Allocate the memory and assign that memory to th2. This address is, I will take some 750. So we need to assign this 750 to th2. Now you have to change this links. How to do this? First we have to assign how to move the th1 value to this th1 value to this node. You have to move the head value. Starting you have to assign th1 is equal to head. Here we already know this th1 is already pointing to first node. That means we need to move. We are entering the position number is 4. The position number is equal to 4. The position number is 4. That means you have to move this pointer to before this one. Before this one means up to third node. Already starting the th1 value is 1. That means head. That means already this one is pointing to first node. That means starting th1 value is 1. Now you have to move this th1 value to, so that means this loop is repeated how many number of times? Already th1 value is 1. That means this one. Next you have to move to this position. Next move to this position. That means 2 and 3. This loop is repeated how many number of times? Only 2 times. Only 2 times you have to move this th1 value to this node. So here I am taking the loop for I is equal to 1, I less than or equal to end position I is equal to I plus 1. Next you have to write the condition. Here the th1 value is head. So next th1 is equal to th1 arrow next. Here the starting th1 value is 500. th1 arrow next means 600. Arrow next means 700. That means how many times this loop is repeated? Position minus 2. Position minus 2 times this loop is repeated. For suppose position is 5, then you have to position minus, position value is 5 means this is 5, this is 1, then this loop is repeated, so 3 times. Now we are moving this th1 to before this node. So I want to write this code. Starting th1 value is equal to head. So for I is equal to 1, I less than or equal to I plus plus. Next we have to move the th1 value is equal to th1 arrow next. Here we have to declare I value. So int I. Now how many times this loop is repeated? Position minus 2. Starting I value is 1. So this one is already, th1 is already pointing to the first node. Now th1 is pointing to the first node. loop is first time repeated, th1 value is 600. Next loop is repeated second time, th1 value is 700. So after completion of this execution, th1 is pointing to our insert position minus 1. That means the th1 is pointing to third node. Here we are entering position is 4. This th1 is pointing to third node. Our position number is 5. th1 is pointing to fourth node. Now we have to insert the node at fourth position. We have to allocate the memory size of link, allocate memory. We have to convert this allocated memory into link star. We have to assign this one into temporary head 2, th2. We have to declare this th2 arrow th2. Now first you have to fill this data. First you have to fill in th2. Now first you have to fill the th2 data. How to fill this? This one is this one is data, this one is next. So this data is id, name, salary. So how to fill this data? th2, here the memory is allocated. th2 is equal to link star malloc size of link. Next you have to fill the data th2 arrow data is equal to get data next th2 arrow next is equal to, so please observe, this one is next node, this one is the next node, this next node is address is 800. Now we have to fill this data is 800. Fill this data is 800. Already this 800 is present in this variable th1 arrow next. That means th2 arrow is equal to th1 arrow next. Now whenever you have to change this one, this one is pointing to this node. So this data is id, name, salary. Here we are entering id is some name. I am entering 500. Name is Durga Ganesh. Durga Ganesh. Salary is some 14,000. So fill this data and then th2 arrow next is equal to, this is the next one is, so this next node is 600, this next node is 700, this next node is th2 750. Here you have to change this one to, to 750. So 750 is present in which variable? th2. This variable is th1 arrow next. Here th1 arrow next is equal to th2. Now this th2 value is 750. Now this one is pointing to this node. Now it is perfect. Next, no need to this th1 and th2. You have to assign th1 is equal to null, th2 is equal to null. These are the local variables. No need to assign. th1 is equal to, th2 is equal to null. These are the local variables. No need to assign null. Whenever control comes to out of the function, this memory is deallocated. The head is a global variable. Now please check, head is 500, this node, next one address is 600, next address is 700, next node is 750, next node is 800. So perfectly this data is inserted. So please check, please convert this one to code. So th2 arrow data is equal to get data. Next one is th2 arrow next. This th2 arrow next. This 800 is present in this starting this variable th1 arrow next is equal to th1 arrow next. Next one is, you have to change this one, th1 arrow next is equal to 750, th2, th1 arrow next is equal to th2, then th1 is equal to, th2 is equal to null. There is no need to write. These are the local. Whenever control comes to out of the function, this memory is deallocated. Okay, so now we have to check this one is working or not. So alt F9, th1 is equal to th1 arrow next. So alt F9, yes, control F9. So exit. So F7, execution is always starts from main function. I am entering flag is 4. So F7, insert, starting value number of nodes is 0. So head is equal to null. So enter ID 1, enter name SMR, enter salary is 16,000. So F7, return, break out of this switch. Once again while loop, once again I am entering insert. Now case 4, insert, number of links is 1. Here the number of nodes is 1, calculated, return value is 1, alt F5, number of nodes is 1. So head is equal to null, condition false, out of the loop. So in this debug this code, I want to show head and th1 and th2. So I want to show you th1 arrow next and th2 arrow next. th2 arrow next. Set is equal to null, condition false, then control comes to this place enter the position to insert. I want to insert at position number 1. Yes, position number 1. So we have only one node. Windows watch. So th1 memory is allocated. The th1 address is changed 0882. This is the th1 address. Next, data, id, name, salary. Id is 2. Name is Manvita. Salary is 16,000. So F7. So please remember th1 arrow, this one is head. Head value is th1 arrow, next is equal to head. Head value is 0854 is assigned to head value is assigned to th1 arrow next. th1 arrow next. Now th1 value is 0882 is assigned to head. Now this is the head value is 088. This is the first node. Next th1 value is null. So return. Now I want to show you display. First node is F7. Display F2. First node is 2. Manvita 16,000. Display. Here the first node is Alt F5 to name Manvita salary. So F7 condition. Second node is first one SMR 16,000. So F7. Okay, now so I want to create two more nodes. So F7, entering the nodes. So one, create nodes, create, control comes to create function, head is equal to null, condition false. Now th1 is moved to last but one node, 1, 2. Now third, this one is the third node, 3, name Kushal Kumar, salary is 15,000. So F7. Do you want one more? Yes, I want one more. Yes. F7. Employee ID is 4. Employee name is Shanmukh Verma. So F7, salary is 17,000. So do you want one more? No. So now total we have how many nodes? 4 nodes. F7. I want to display that one. I want to enter 2 for display the number of nodes. Case 2. F7 display head is equal to null, condition false. This loop is repeated 4 times. One, first time, first employee data, second time, second employee data, third time, third employee data, fourth time, fourth employee data. Condition false, out of the loop. Out of the switch, next main method. So Alt F5, this is the employee data. First 2, 1, 3. Now I want to insert at position number 4 in between 3 and 4. So once I am giving insert 4. So case 4, insert function. Now I will show you the so F7 number of nodes is 4. So Alt F5 number of nodes is 4. So F7 enter the position. Here I am entering at position number 4 in between 3 and 4. Now this condition false, position is equal to 1, this condition also false, then control comes to other than position 1. Here other than position 1, F7. Now this loop is repeated 2 times. TH1 value is starting, TH1 value is head value is this one. This loop is repeated 2 times. Now TH1 value is changed to 5 4. Next second time TH1 is point next. Now TH2 is memory is allocated. TH2 initial value is garbage value. This statement, I want to delete this one. So memory is allocated and assign that memory to TH2. Now TH2 value is 090C. Now TH2 arrow data is entering 5. Durga Ganesh, salary is 18,000. So F7. Now TH1, TH2 arrow next. TH2 arrow next. Now TH2 arrow next, TH1 arrow next value is this one 08DE is changed here. So F7, yes. Next TH1 arrow next is TH2. TH2 value this one. This one is changed here 090C. Next these two values are null. So break. Once again out of the switch, once again main. I want to enter, display the data, to enter 2. So F7. So it is equal to null, condition false. This loop is repeated 5 times. 1, 2, the employee 2, alt F5, 2, 1. Next employee 3, alt F5. Now ID is 5, name is Durga Ganesh, salary is our interval F7. Fourth record is at 4th position. We have to enter the 4th position, employee ID 5. This is the ID number 4. Out of the loop, out of the break, enter some 7 out of the while. So this is the insert. So please refer once again. In next video we will discuss delete. We know how to create, insert, delete. Then you have to stack and queue are very easy. Thank you for watching. Bye. Hi everybody. Welcome to SMR Telugu Education. So next topic is deletion in linked list. So how to delete an element in linked list? First, so in our main method, here you have to copy, control insert, shift insert. Enter 5 for delete nodes. Enter 5 for delete nodes. Delete nodes. Here entering flag value is 5, then switch value is 5, then case 5. Here you have to write case 5. Case 5. So there is a predefined keyword is called delete in C++. That's why I am using the function name is delete node and then break. Here you have to write. So return type is no return type, void. Function name is delete node, no parameters, open curly brace and close curly brace. This is called function definition. This is called function definition. Here head is a global variable. First you have to check head is null or not. If head is equal to null, that means list is empty, deletion is not possible. So print, give that statement and then return. So slash n, list is empty, and then return. So F2 save. So F7. So we'll get an error because this is function definition. We need to declare that function in main method. First you have to define that one. Declaration is function name, return type, no return type, function name, delete node, then no parameters. This is called function declaration. So our execution is always starts from main method or main function. So F7 is first while of infinity loop, then enter flag value. Here I am entering 5. So flag value is 5, then it is goes to case 5, then call delete node function, then control comes to delete node function. Now we check head is equal to null. Yes, condition true, head is equal to null, list is empty, and then return out of the function definition, and then go to switch and then break. Next once again while loop. So this is first case. Alt F5, enter 1 for nodes. So Alt F9, yes. Now first you have to delete a node. First display. First you have to calculate the number of nodes in a list. Here I am calling so int number of list. So number of list is equal to there is a function called number of nodes or number of list. First you have to check the function name, number of nodes. So number of nodes. First here I am printing the number of nodes slash n. So number of nodes percentage d comma nl. Now display the number of nodes is 0. Next here ask the end user to enter the position, to enter the link number. Do you want to delete? Okay. So printf, ask the end user enter link number to delete. So here I am defining one variable is called link number int link l underscore number, link number. So scan that value, scanf percentage d comma address of link underscore number, link number. So for suppose here I am entering link number is less than 0 and greater than number of links, that means deletion is not possible. This is our linked list. This is first node, second node, third node, fourth, and then fifth, and then sixth. Total 6 nodes. Here starting address is, writing starting address is 500. Next node is 600. Next node is 700. Next node is 800. Next node is 900. Next node is 1000. Here head node is this one is head. So head starting value is 500. So head is pointing to this node. Here this address is 600, this address is 700. Here this value is 600, 700, 800, 900, 1000, then null value. So this one is pointing to this node. This node 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 is pointing to this node. So in this total how many nodes? 1, 2, 3, 4, 6 nodes. I want to delete either 1 or 6. For suppose our enter link is either less than 0 or greater than number of links, then it is invalid position to delete. So first you have to check the condition. If link number is less than 0 or link number is greater than number of links, then invalid position and then return. Give a message printf invalid position and then return. First you have to check up to this. So alt F9. Yes, our execution is always starts from main function, then while of infinity loop. So here I am entering 5 for delete nodes. Here link case 5, flag value is 5, then case 5, control comes to case 5, delete node. This function is calling, then control comes to this function calling. So first calculate the number of nodes, then control goes to number of nodes function. Number of nodes is 0, return 0. The return value is assigned in NL. Number of nodes is 0. Now head value is 0, S true, list is empty, and then return. Break out of the switch, once again while loop. Now I am deleting. So alt F9, 5. So I want to enter 1 for create nodes. 1 ID is 1, employee name is SMR, salary is 16,000. Do you want one more? No. Then 5. So we have total only first display node. We have one node, 1 ID, 1 name, salary. Here I want to delete for link number 2. it is not available, invalid position. 2 5 for delete nodes, number of nodes is 1, enter the link number to delete 2, invalid position. Once again 5, number of links to delete, enter link number to delete, entering 0, less than 0, then invalid position. So exit 8. No, if link number is less than 0, less than or equal to 0. 0 is also not possible. 0th link less than or equal to 0 and greater than number of links. It is invalid position. Alt F9, yes. Now I am entering one node. So first case 1. This is our empty. Here head is a global variable. This one is head. Here the address is 500. This 500 is stored in head. This one is pointing to this one. This one is data. This one is data. This one is next. So please remember, here the number of links is 1. That means we have only one node. That value is present in head node. Here the head is a global variable. So global variable default value is null. So by using free function, here how to delete this one? First you have to check if number of links is equal to 1, number of nodes is equal to 1, number of nodes or number of links is equal to 1, then we have to delete the head node. There is a function called free of head. So please remember this function free of head, this function. So what is the value of head? Value of head is 500. So 500 address node is this data. So this function deletes this data. That means this data is not available. Now what is the value of head? Value of head is 500. But this 500 address value is not available. This value is not available. This is called dangling pointers. So first you have to remove this one. Next one is, please remember, you have to assign head value to null. So head is equal to null. Yes, so compulsory you have to write this is a global variable. So compulsory you have to assign null value. That means here the head value is, this head value is null and then return. Head value is null and then return. So first write this one in our code. So here if the number of links NL is equal to 1, that means only head node, we have to remove that one by using free of head. So memory is deallocated, and then a head value is assigned to null. So compulsory you have to write null, otherwise it is a global variable, and then return. So first I have to check up to this one, alt F9, yes, control F9. So display nodes, list is an empty, 2, list is an empty, entering 1 for create nodes, 1 SMR, and then salary is 16,000. Do you want one more? No. So number of nodes 3, number of nodes is 1, display nodes 2, 1 ID, name, SMR, and salary, and then exit. So F7, I want to show you the execution. For create, first delete 5, flag value is 5, case 5, then control goes to delete node, then this function is executing. So number of nodes is 0, head is equal to null, yes, true, list is empty, and then return. Out of the function definition, out of the switch, then main function. Here I am entering one node, 1 F7, create nodes, head is equal to null, yes, condition true, then data, enter ID, name, SMR, and then salary is 16,000, F7. So do you want one more? No. So out of the create function, then out of the switch, once again menu. Now I want to delete the fifth, delete the node. Now we have only one node, that is called head node. That node address is pointing to head node. So delete node, number of nodes is 1, condition false, 1 false, number of nodes is equal to 1, head is equal to null, condition false. Then control comes to this statement, ask the enter link number to delete. So I want to enter 2, invalid position. So F7, condition to invalid position, and then return. Out of the switch, once again menu. Here I am entering 5, delete node, case 5, delete node, number of nodes 1, head is equal to null, condition false, enter link number. Here I am entering 1. So this condition is false. Next F7, this one is true, free of head. So F7, this is deallocate the memory, head is equal to null, and then return. Now out of this switch, and then display the data 2. Now head is equal to null, that means list is empty. So F7, display head is equal to null, yes, true, list is empty, and then return. Out of this switch, and then menu. So 8 out of this one is the first case. So another case is delete the node, this is one node, this is another node, this one is the another node. Here head, here I am taking starting node is 500, next one is 600, then 700. So this one is 500. So this is head node, this 500 is stored here. So this one is pointing to this node. Next one is This is the next node, next node, next node. The next node is 600, next node is 700, next one is null. So in first case only one link, only number of links is 1, then you have to remove this one. Next case is head, number of links is, here in this case the number of links is 1, 2, 3, but I want to delete the link number is first. This is another case, I want to delete the first. Number of links is equal to 1. Then how to delete this first node? So if link underscore number is equal to 1, then how to delete? So please remember, we have to delete this one. How to delete this one? We have to take one temporary head. Take one temporary head. Take one temporary head and assign this head value to temporary head is equal to 500. Now this one is pointing to this node. Now so we have to move this, we have to assign this head value to, so here you have to remove this node. So here our aim is to remove this node. Then next node is this one, next node is this one. So you have to assign this 600 to head. So how to write? First take one temporary head of type. First you have to define link star temporary head and assign head value to temporary head. Then head value is 600. So head value you have to assign head is equal to 600. This 600 is present in which variable? th arrow next. So head is equal to th arrow next. Now our head value is 600. Now this link is no more. This 600 is, this one is pointing to this one. Our head is 600, next is 700. Okay. Now next you have to remove this one. Remove this 500. How to remove? By using free function. So free of th. So please remember this free of th function deletes this node. Still th value is 500. Now we have to assign th value is equal to null. So no need, this is the local variable. Whenever control goes to out of the function definition, this is automatically null value. So instead of th you have to take temporary head 1, th1 and so on. Okay. So you have to write this code. So how to write? First take one temporary head 1 of type declare, so link asterisk th1. Next th1 is equal to head. Next head value is changed to 600. Head is equal, that 600 value is present in which variable? th1 arrow next. Next you have to free the th1, still th1 value is 500, you have to assign to null, so no need, it is a local variable, and then return, it deletes the first node. So this is the code for link is list is empty, then this is the condition, list is only one node, this is the condition. So list is more than one node and still you have to delete the first node, this is the condition. So check up to this, Alt F9, yes, F7. So 1, create nodes, z is equal to null s true, employee id 1, so employee name SMR, so employee salary is 16,000. Next F7, do you want one more? Yes, 2, F7, employee id 2, employee name Manvita, employee salary is 17,000. So F7, do you want one more? Yes. So F7, employee id 3, employee name Kushal Kumar, salary is 18,000. So F7, so no, so total we have 3 nodes. So I am entering, now I want to enter display the nodes 2. So F7, display it is equal to null, false, first node, second node, third node, total 3 nodes, condition false, out of the loop, out of the break, and then once again main, Alt F5. Here first node, second node, third node. Here I want to delete the first node. So here I am giving 5, case 5, F7, 5. So case 5, delete node, yes. So number of nodes is 3, 1, 2, 3. That is equal to null, condition false. Ask the link number to delete. I want to delete first node. So F7. So number of links is equal to 1. Condition false. This link number is equal to 1. Yes, condition true. Then th is equal to head. Head is equal to th1 arrow next. Free of th1. th1 is equal to null and then return. Out of the break. Now I want to display the nodes 2. First node is deleted, 2, 3. Only 2 nodes, 1, 2. ID number 2 and 3 are display, break. Alt F5. So 2, 3. First node is deleted. Next case is here I want to delete so link number 4. In this case here I want to delete the link number 4, this one. So I want to delete this node. Here you have to enter the link number. Here in insertion you have to take the same, you have to move 2 temporary heads, th1 is assigned to head, then you have to move the th1 to the before this node, before. Here the link number is, here I want to delete link number is 4, then starting value is 1. Here you have to reach 4, delete 4, that means 2, 3. This loop is repeated how many number of times? 2 times. Then you have to move the th1 to the th1 arrow next. Here starting th1 value is 500, you have to move this loop for 2 times. So I is equal to 1, I less than or equal to link underscore number minus 2 I plus plus. For suppose our link number is 5, then you have to move to 3 times. So link number minus 2. Here the th1 starting value is 500. First time this loop is first time repeated. th1 is equal to th1 arrow next. Here the th1 value is 600. th1 value is 600. Next time I value is incremented by 1, 2 less than or equal to 2 as condition true. Next th1 value is 700. Now th1 is pointing to this node. Now th1 is pointing to this node. Next you have to assign th2 value to 800. Now this th2 value is pointing to our deleted node. This is our deleted node. This is the first node, second node, third node. This is the third node. Here we need to delete this node. So this value is changed to, we need to delete this node 800 node. This value is changed to 900. So how to change? What this node is th1 arrow next. th1 arrow next value is replaced with 900. This 900 is present in th2 arrow next. So th1 arrow next is replaced with th2 arrow next. Now this value is 900. Now this link is pointing to this one. Now head is 500, 600, 700, next 900, next 1000. Next you have to delete this node. So how to delete? Just free of th2. Free of th2. So please remember, free of th2, just delete this node, this value. But still th1 value is 700, th2 value is 800. You have to assign th1 is equal to th2 is equal to null. So how to convert this one? How to convert? First you have to take temporary head th1 and th2. This one is other than 1. Here you have to take temporary head 1 comma temporary head 2. So th1 is equal to head. Here for loop purpose I am taking I value int I. For I is equal to 1, I less than or equal to link underscore number minus 2. Same in insertion you have to move the position number 1 to before node same I plus plus, we have to th1 is equal to th1 arrow next. Now th1 is pointing to the before the up to this code, our th1 is pointing to this node. Next th2 is 800. This th2 value is th1 arrow next. 800 is assigned to th2. th2 is equal to th1 arrow next. After writing this one, you have to change this value th1 arrow next value with th2 arrow next. th1 arrow next is equal to th2 arrow next. Next remove th2 by using free function th2 and then assign th1 is equal to th2 is equal to null value. No need, these are the local variables. Whenever control goes to out of the function definition, this memory is automatically deallocated. Now I have to check F7. So I want to debug this code. Here I want to show you head value th1 value th2 value th1 arrow next value th2 arrow next value. So F7. First here I want to insert the data. ID1 name, so SMR, so salary is 16,000. So F7. Do you want one more record? Yes. So F7. So do you want one? So by mistake you entered. So once again Alt F9. Yes. Alt F9. Yes. So create one, create links, enter one, employee name SMR, so employee salary is 16,000. So F7. Do you want one more? Yes. Employee ID 2, employee name Manvita, so employee salary is 17,000. So F7. Do you want one more? Yes. Employee name, employee ID 3, employee name Kushal Kumar, employee salary is 19,000. So do you want one more? Yes. So F7. 4, some name Raja, some salary 17,000. So F7. Do you want one more? Yes. So total you have 5. This is 5th record I am entering. 5 employee name Shanmukh Verma, employee salary is 20,000. F7. So do you want one more? No. Now I want to show you, first I want to show you display. Windows, watch, say F7. First show you display, F7, yes. Display function is executed, head is equal to null, condition false. So here I want to show you th value also, th. Now head, th is equal to head, F7, head value is 08C8. So th not total 5 times, F7 first data, next th value change to 08F6, next th value is 0924, next th value is 0952, next address is 0952, next th value is 0980, next th value is null, null not equal to null, condition false, out of the loop. So break, total 5 records. Now here I want to delete ID number 4. So delete node. Here I want to enter the link number is, number of nodes is 4, 5. This loop is repeated 5 times. 1, 2, 3, 4, 5. Return value is replaced here. That is equal to condition false. Here the link number to delete, 4th link. So please remember, 4th link means this is condition false, this is condition false. Control comes here. Now our th1 and th2. So I want to delete this record. Here head value is, first head value is assigned to th1. Now this loop is repeated 2 times. First time th1 value is th1 arrow next 08F6 first time, next second time 0924. Now our th1 is pointing to the 3rd node. Now th2 value is th1 arrow next. This is the th2 0952. Now th1 arrow next, this value is replaced with th2 arrow next 80. Now free of th2. Now this 0952 is deleted. Now th1 and th2 values is null values. So I want to give display, say F7, display. This loop is repeated first time, second time, 3rd time, 4th time. Break out of this switch, Alt F5. So in this ID number 4 is deleted. F7, exit any, 9, exit. So this is delete. Head is equal to null, one case. Number of links is 1, you have to delete the head node and head is equal to null. Number of links is present, but you have to delete the first node is one condition. Other than first node, this is another condition. This is delete. So please refer. Once again, thank you for watching. Hi everybody, welcome to SMR Telugu Education. So next topic is reverse of linked list. So how to find reverse of linked list. Reverse of linked list. So this is our linked list. This is head. This is one node. Base address is 500. This is another node. Another node. Next node. This 600 is present in this node. Next node address 700 is stored here. Next 800 is here. 900 is here. So next node is null. Here you have to find out the reverse. This is the first node. Here head value is 900. That means head value is 900. This is the first node. Here you have to change this value to previous node. Here you have to change this address to previous node. Changed here value to previous node. Next here you have to change the previous node is null. So how to do this? Here first, here I am taking 3 nodes. First node, second node, and a third node. So first node, second node, then third node. Here first node is 500. First node is 500. Next node is 600. Next node is 700. Here head value is, this is head. So head value is 500. Now this one is pointing to this node. Here the next node is here the next node is 600, but you have to reverse this one. How to do this? First you have to head. Here you have to take 3 variables of type link star type struct to pointer. Here this is the data, this is next. This is data part, this one is next link part, next node address. Here this is 600. So how to reverse this? So how to reverse? First here assign this, take this one as a current node. So current value is equal to 500. First here you have to assign take this node as current node. Next this one is next node. This one is next node. So take this one is the previous node. So previous node is not available, then you have to take null value. So previous node is not available, then take the previous as null value. Now you have to change this one. Here you have to move the next one to next, and current value is moved to next, and previous value is moved to current value. So first here you have to replace, first here you have to move the current value, so next value. So here the next value is 600. How to get 600? current arrow next. So next is equal to current arrow next. Now our next is pointing to this node. Now next you have to fill this one. At the time of reverse, this is the previous node address. This previous node is starting value is null value. That means you have to assign current arrow next value is equal to previous. So in first case the next value is 600. Current arrow next, here this value is previous value. So previous value is null value. Next here you have to move the current node to next. Next here you have to move the previous to current. First you have to move, next previous is next previous is 500 and current is next. Current is next. So to write, first here you have to assign previous value is equal to current. That means the current value 500 is assigned to previous. That means the previous value is 500. Now current value is equal to next. So in this, so previous value is pointing to this location, current value is pointing to this location. Once again next value is current arrow next. Here current value is 600, current arrow next is this is the 700. So this one is 800. So next node address is 800. So this one is pointing to here. So next node is 900. Next node address is 900. This 900 is present here. You have to move this one. Next at the end, this is a null. Next the current arrow next. Now the next is pointing to this node. Now the current arrow next is this one is current arrow next is replaced with previous. Here the previous value is 500. Now this value is replaced with 500. Next previous value is changed to, now this previous value is changed to pointing to 600. Next current value is pointing to this 700. Next value is pointing to this 800. So once again here you have to copy this value. Current arrow next is previous. So previous value is 600. Next previous is, now the previous is pointing to this 700. Next current value is pointing to 800. Next is pointing to 900. Next, so previous value is, current value is 800. Current arrow next, this value is replaced with previous node. So previous node is 700. So this address is 700 is stored here. Next one is previous value. So previous value should be 800. Current value should be 900. Next value should be 900 arrow. Current value is pointing to, current value is 800. 800 arrow next. So value is this 800 arrow next. So current value is pointing to next node. Next node is not available. That means the current next value is null. At the end, next value is equal to null. So current node is 900. 900 arrow next null value. This null value is next. Next one is current arrow next. The current value is 800 arrow next. This value should be replaced with previous. So present current value is 900. 900 next value is replaced with previous. So previous value is 800. Next previous is equal to current. That means next previous is 900. Next current is null. Current is equal to next. Next current value is null. So this should be repeat the same procedure. You have to copy the previous value into current arrow next and move the previous to current and move the current to next. Same procedure is repeated up to current value is not equal to null. So these steps are repeat up to, so current value is not equal to null. At the end our previous value is 900. Here you have to assign our 900 value into head. Here head value is head value is 900. Now our head is pointing to our head is pointing to 900. Next node is 800 is pointing to this address. Next is 700. This one is pointing to this one. Next is 700. Next node is 600. This one is pointing to this one. Next 500. This node is pointing to this one. Next null. Here you have to, our head value is our last node. This is the reverse. So how to convert this one into code? First in main method or main function you have to write copy, control insert, shift insert. So enter 6 for reverse nodes. A flag value is 6, then K6 is executed. K6, a function name is reverse and then break. So this is called a function calling. you have to declare this function. So return type is void, function name is reverse, no parameters. This is called function declaration. Next you have to write the function definition. So no return type, function name, reverse, no parameters. This is called function definition. Here first you have to take the parameters. Previous is starting is, so previous is null. This is the current node. Next this is the next node. First here you have to assign previous and current. So these are pointer types. So type is link asterisk previous, starting value is equal to null, link asterisk current value, starting value is equal to head, link next, initial value is garbage value. You have to repeat while current value not is equal to null. You have to repeat these steps. First you have to take the next address is move the current value to the next. That means starting current value is 500, next node is 600 node. How to get 600? Current arrow next. First you have to move the next to this node, and here replace this value with the previous node. So this value is, this is the current, starting this is the current. So first you have to move, you have to assign next node to next. This is the current node, this is the, so previous node is null, previous is equal to null. Next you have to move the next to current arrow next. Next current arrow next is equal to previous. Current arrow next is equal to previous. Next you have to move previous value to current value. Here you have to move previous value to so previous is equal to current. That means current value is 500. This 500 is copied into previous. Now previous is pointing to this node. Next you have to move current value is equal to next. Current value is equal to next. Now the current value is 600. So say these steps are repeat until the current value is pointing to null value. So previous value is equal to current, then current value is equal to next. These steps are repeat up to current value is not equal to null. The current value is next here. So next step, next is equal to, so next is equal to 700. Now this value, starting this value is null. first case the previous value is null, that null is stored here. Null. Next one is here you have to move the previous node. The previous node is 500. So this address is 500. After 500 you have to move the previous to this one. Now this value is previous. So previous is equal to 600. Next this value is current. Next this value is current. So once again current value is 700. So current value not equal to null. Yes, condition true. Once again next node is, this is the next node. So next node is 800. Next current arrow, next this value is previous node. So previous node is 600. Next you have to move the previous value to here. Now previous is 700. Now the current value is current value is 800. So current value 800 not equal to 0. Yes, condition true. Once again next is equal to current arrow next. So next is equal to 900. Next current arrow next. This is the previous node. Previous node is 700. This is present in previous. So this is previous. Next one is you have to move previous value to current. Here you have to move this previous to previous. Next here we have to move current value to next. So once again current value is 900. So 900 not equal to null. Yes, condition true. Once again next is equal to current arrow next. That means next is equal to null. So next value is null. Then move this previous value. The previous value is 700. Here you have to move previous value is 800 is here. Assign previous value into current arrow next. This is 800. So next you have to move previous value is equal to previous value to next node. Then current value is equal to next. So current value is equal to next. Next value is null. Yes. So if current value is null, null not equal to null, condition false, out of the loop. After whenever control goes to out of the loop, so out of the loop, here you have to assign previous value into head. Our previous value is 900. This 900 is assigned to head. Now So head value is previous, so previous value is 900. So next, this 900 is pointing to this node. This is the head, first node. Next is 800. This one is pointing to 800 node. Next, this one is 700. Next node is this one. Next node is this one. Next node is this one. Next, null character. This is the reverse of a linked list. That's it. So Alt F9, yes, Control F9. First, create the linked list 1, employee ID SMR, employee salary 16,000. Do you want one more? Yes. Employee ID 2, employee name, so Manvita salary is 17,000. Do you want one more? Yes. Employee ID 3, employee name Kushal Kumar, salary is 18,000. Do you want one more? Yes. 4, employee name Shanmukh Verma, salary is 19,000. One more? Yes. Employee ID 5, name is Durga Ganesh, salary is 20,000. One more? No. I want to display the nodes. Total 5 nodes. 1, 2, 3, 4, 5. Now reverse the linked list. Here I want to enter 6. So reverse is 5, 4, 3, 2, 1. Once again display 5, 4, 3, 2, 1. This is the reverse of a linked list. So first, if you want, you can check the if a head is equal to null, list is empty, and then return. So printf /n list is empty and then return. So Alt F9, yes, Control F9, directly 6. So head is list is empty. So once again 1, employee ID, employee name, employee salary. One more? No. So here number of records is 1. I want to reverse the linked list. 6, only one record. 2, only 1. So enter one more. 1, employee ID, 2, employee name, Manvita, salary is 17,000. Do you want one more? No. So display 1, 2, reverse 6, display 2, 1. So this is the reverse of linked list, and exit, enter any. So first here you have to debug this code. Okay, you have to try. So still you have any doubts, please refer once again. Thank you for watching. Bye.